Okay, today we're going to look at the chain rule. The chain rule is one of the most powerful differentiation rules. It allows us to use the derivative of composite functions. If y is equal to f of u is a differential function of the variable u, and u g of x is a differential function of the variable x, then to find the derivative of composite function, a function inside of another function, what you're going to do is you're going to take the derivative of the outside function times the derivative of the inside function. Now, in calculus notation, that would be the derivative of y with respect to x will be equal to the derivative of y with respect to u. So that's our outside function's derivative, times by the derivative of u with respect to x. So that's the derivative of the inside function. So that's all the chain rule pretty much says. If you're going to take a derivative of a composite function, you take the derivative of the outside function times by the derivative of the inside function. Now, if we use function notation that you learned in college algebra, we could rewrite y as y is equal to f of g of x. Remember, that was our composite notation used in college algebra. And if this is all differential with respect to x, we could also rewrite the chain rule using calculus notation to say the following. The derivative of f of g of x with respect to x is equal to the derivative of f, so the derivative of f, that's our outside function, times by the derivative of the inside function, or the derivative of g. And that's how you do the chain rule. So anytime you want to find the derivative of a composite function, you take the derivative of the outside times the derivative of the inside. So our first little thing that we want to do is to be able to identify what our inside function is and what our outside function is. So looking at problem number A here, we can identify that our inside function is 2x cubed plus 3x squared minus 4x plus 1. So that's like our u. That's our inside of our function. So that's our inside function. And so what's our outside function? Well, it's going to be that u raised to the 12th power. So that u to the 12th is what we consider our outside function. So that u is what we call our inside function, and then u to the 12th, that thing raised to the 12th power, is our outside function. So to find the derivative of y with respect to x, so we're going to differentiate that u to the 12th, and so the derivative of y with respect to u is going to be the derivative of u to the 12th, which is 12u to the 11th, and I'm going to write u as that 2x cubed plus 3x squared minus the 4x plus the 1. So that's my derivative of u to the 12th. That's the outside derivative. Then I need to multiply this by the derivative of the inside function, derivative of u with respect to x. So up here is my u value. And so we're going to differentiate that inside function. So derivative of 2x cubed is 6x squared, plus the derivative of 3x squared is 6x, minus derivative of 4x is 4, and derivative of 1 is 0. Now it's just algebra and simplifying it down. So notice, again, chain rule, derivative of the outside, that's what is in the green, times by the derivative of the inside, which is what I wrote in the orange. So doing some algebra and cleaning it up, I'm going to take that 12, and we need to multiply it by that 6x squared plus the 6x minus the 4. And then I'm going to just leave that 2x cubed plus 3x squared minus 4x plus 1 to the 11th power by itself, because that's to the 11th power. So remember, we can't distribute into an exponent, into a power. So, but the first two here, these two I can combine, and that's what you will need to do. And so I'm going to distribute that 12x to each term inside the first set of parentheses. So 12x times 6x squared gives me 72x squared plus 72x minus 48. And all of that polynomial, so it needs to be all in parentheses, is times by the 2x cubed plus 3x squared minus 4x plus 1 raised to 11th power. And that's it. You can't simplify that. You can't combine that out, because we do not want to multiply that second polynomial 11 times together. That's just ridiculous. And so that's how you do the chain rule. So I want you to try this one. I want you to find the derivative of y with respect y if it's equal to 5x minus 3 to the 4th power. Okay, so first thing we need to do is identify our inside function. So our inside function is 5x minus 3. So we're going to let that be our u. So 5x minus 3 is equal to our u. Then this is our inside function. Now we need to identify the outside function. And so our outside function is going to be that u raised to the 4th power. So that's our outside function. Okay, define the derivative of this y, or define derivative of y with respect to x. So we're going to find the derivative of the outside times the derivative of the inside. The derivative of the outside here is that u to the 4th derivative, which is 4u cubed. And then the derivative of the inside is derivative of that 5x minus 3, which is just 5. Now remember, u is 5x minus 3. So we have 4 times 5x minus 3 cubed times 5. I do have some like terms I can combine. I can multiply the 4 and the 5 together to simplify this polynomial down. And I will get 20 times 5x minus 3 quantity cubed. And that is the derivative of this problem. Now, derivatives will also, we will also combine all the other differentiation rules with the chain rule. So in this problem, we have 2x minus 1 to the 5th power times x squared minus 3x plus 5 to the 9th power. So we have a product rule, two polynomials multiplied together, but we also have two chain rules, because we have 2x minus 1 is the inside of this first term, and we have x squared minus 3x plus 5, the inside function of the 9th power term. So we're going to have to do the chain rule twice in this problem in addition to the product rule. So how would we start? Well, we'll start with the product rule. So again, the derivative of y with respect to x is going to be equal to our first term times by the derivative of the second term. Now, in order to find the derivative of x squared minus 3x plus 5 to the 9th power, I'm going to have to use the chain rule to find the derivative of this second term. Our chain rule is 9 times our inside function, which is x squared minus 3x plus 5 to the 8th power, and then times by, because that's the derivative of the outside function. And now I need to times by the derivative of the inside function, which is just simply 2x minus 3. Now that's only the first part of the product rule. That's first term times the derivative of the second. Now remember, we need to add our second term times by the derivative of the first. So we have to finish the product rule. A lot of people forget this part. So we have our second function. We just copy it down like it is. And I'm going to multiply by the derivative of the first function, which is, again, a chain rule problem. So my inside function this time is 2x minus 1. So u to the 5th is my outside function. So the derivative of that is 5u to the 4th. Times by the derivative of my inside, which is just 2. All right, so we're going to clean this up. So what I usually do is those brackets, we're going to start combining any like terms we can in those brackets to make them easier. So in our first bracket here, I know I see a 9 in that 2x minus 3. Those are not raised to any power, so I can combine those together by just distributing the 9 to each term in that in the second parentheses there. And so we're not going to do anything with this 2x minus 1 to the 5th. But inside this bracket, I'm going to rewrite this as 18x minus the 27. And I still have this times by the polynomial x squared minus 3x plus 5 to the 8th power. Okay, now on the next section, I'm going to see if I can simplify what's in its brackets. And the only thing I can simplify in those brackets is 5 times 2. So we have plus x squared minus 3x plus 5 to the 9th power, which we can't do anything x, times by 10, which is 5 times 2, times by 2x minus 1 to the 4th power. Now, notice I now have two terms. The 2x minus 1 to the 5th times 18x minus 27 times x squared minus 3x plus 5 to the 8th power is all one term, because those are all products, plus my second term is that 10 times x squared minus 3x plus 5 to the 9th times the 2x minus 1 to the 4th. I'm just going to write it so you can see it a little better. I think those brackets are a little confusing. It makes it misleading what the two terms are. So I'm just cleaning it up a little bit for you. So like I said earlier, here is our first term, and this is our second term. So we're going to look at those two terms and say what's in common in those two terms. Well, the first thing I notice is both of those terms have a 2x minus 1 factor. The first one has it 5 times, the second one has it 4 times. So I'm going to factor out 4 of them. You factor out the one that's in common in all of them. So that's the first thing I'm going to factor out. I'm going to factor out the 2x minus 1, and I'm going to factor out to the 4th power, 4 of those. Then I also notice that both of those terms have x squared minus 3x plus 5 in common. In the first term, I have it 8 times, and in the second term, I had it 9 times. So I'm going to factor out 8 of those, because that's the most that's in common in the two. And so now, in that first term, I've taken out 4 of those, so I am left with 2x minus 1. I haven't done anything with that 18x minus 27, so I need to times this by 18x minus 27. But I've factored out all 8 of those x squares minus 3x plus 5, so there's no longer any in that term. Now in the second term, I still have the 10. I factor out 8 of the quadratic terms, so I still have 1 of those. And I took out all of the x squared minus 1 factors. Once you do this, what we're going to do is now we're going to combine any like terms, simplify what's inside the bracket using some algebraic techniques. So first thing I have is two linear terms multiplied together, so I'm going to have to use the full method. Remember, full is our first terms multiplied together, which will give us 36x squared, and then our outer terms, which will be a negative 54x, minus then our inside terms, and then our last terms. And then on this one, I'm just going to do the distributive property, distribute the 10 to each term in the last set of parentheses. Okay, still working in this bracket. The last thing I'm going to do is combine all my like terms. So I have a 36x squared, and I'm going to add that to add a 10x squared to give us 46x squared. Now I'm going to combine my negative 54x, our negative 18x, and our negative 30x to get a negative 102x. And then last but not least, I'm going to add 27 to 50 to get plus 77. And this is our final answer. I'm going to change this bracket to a parenthesis so it looks a little better. And that is the derivative of this function. Okay, now let's do one more. This one's your turn. This time I'm going to try the derivative of this fraction cubed. Okay, so you're going to have to do the chain rule and a quotient rule. So I notice I have an inside function of 5x squared divided by 3x squared plus 2. So that's my inside function. So that's going to be my u. And so u cubed is my outside function. So I'm going to start to find the derivative of this. I want to take my derivative of my outside function. So the derivative of u cubed is 3u squared. And u is defined as 5x squared divided by 3x squared plus 2. Okay, now I need to multiply this by the derivative of the inside. And to find the derivative of the inside, I need to use the quotient rule. Okay, so let's remember what the quotient rule is. Quotient rule is low, d high, so the derivative of top would be 10x, minus high, so that's 5x squared, d low, and derivative of the bottom is 6x, over low, low. So I write the bottom and I square it. All right, so again, let's start with simplifying down the bracket. Okay, on the top, we can distribute that 10x to the 3x squared and to the 2 to get a 30x cubed plus a 20x. And then we can distribute the negative and the 5x squared to the 6x. Multiplying that together, we get negative 30x cubed, all over our denominator of 3x squared plus 2 quantity squared. Now remember from college algebra, when you have a fraction inside of a power, we can distribute that power to the top and the bottom. So I can rewrite this as 5x squared quantity squared and 3x squared plus 2 quantity squared. And then inside this bracket, I can simplify this down to just 20x over 3x squared plus 2 quantity squared. All right, remember we take something to a power, you distribute that power to each base. So that's going to be 25x to the 4th over 3x squared plus 2 to the 4th power. Or to the 2nd power. I said 4th, didn't I? To the 2nd power. And then I'm going to times that by our 20x over 3x squared plus 2 quantity squared. So now, remember when we're multiplying that, we multiply straight across the top and straight across the bottom to multiply fractions. And so that's going to give me 3 times 27x to the 4th, which will be 75x to the 4th, times by 20x. And then on bottom, that's going to give me the 3x squared plus 2 to the 4th power. And last but not least, I need to multiply 75x to the 4th times by 20x. 1,500 x to the 5th over 3x squared plus 2 to the 4th power. And that's how you find derivatives that involve composite functions when you have a derivative, when you have a function inside of another function.